Okay, so 7.4 is property of logarithms. So as we are moving forward here with the logarithms, now we're going to get into a lesson that really, once you understand this lesson, it's very, very, very simple. There's really three things that we're looking at here, but um, there's not a whole lot to this until we get into 7.5, is where we really use these properties. So today's a lot about practicing. And really what we're doing is we're going to expand logarithm problems and we're going to condense logarithm problems by looking at the three properties. The first property of which is the product property. And when it's written this way, log base b of m times n, so this could be a 5 times x, this could be a 7 times 2, we can expand that, and by expanding it, we're going to make it longer, meaning we're going to write the log out more than one time. So if I gave you a simple problem that was log of, like I said, 5 times x, I could rewrite that as log of 5 plus log of x. So we're expanding that problem, and these work both ways. If I had log of 5 plus log of x, I could rewrite that as log of 5x. We're really just going to be practicing on going from one form to the other. And if you think about it, we talked about this yesterday. Logarithms are nothing more than exponents. Well, what did we do when we had the same base, and we were multiplying exponents? We added them, correct? So if you think about the rules of exponents and logarithms, they're kind of the same. They just look a little different because of the way they're written with the logarithm. So the quotient property, if you have log of b times m over n, we're going to subtract those just like we would with exponents. So if I had log base 4 of y over z, that would be the same thing as log base 4, the log doesn't change, of y minus log base 4 of z. Okay, and then the power product, what did we do with a power of a power? We multiply them, right? So if I have log base b of m to the n, we can actually take the n outside in front, and it moves to the front and becomes multiplication. So if I had log of, let's just say, base 3.2, just make something that looks different, of x to the 5th power, this would be the same exact thing of moving the 5 to the front and writing log base 3.2 of x. So again, anytime you see a number out in front, it means it's an exponent. Anytime you see subtraction, it means it's division. And anytime you see a plus sign, it means multiplication. So let's look at a couple of examples here. Starting off really simple. Okay, simplify logs by condensing. So we see the subtraction. We're going to write the log base 4 one time. I'm going to put the 32 over 2. Okay, again, this subtraction sign means division, and then I can actually do the math here. Log base 4 of 32 divided by 2 is 16. So what does this mean? Well, think about what we did yesterday. This means 4 to some power equals 16, right? 4 to some power, well, that would be squared. So this is the same exact thing as writing the number 2. This problem here, we're going to kind of have a couple of things here. You see the plus sign, and you see, we'll do this in 2 steps. If you see a number out in front, that means automatically that it is an exponent. So we're going to move that out to the front, from the front onto the exponent. So this would be log base 2 of x to the 6th plus log base 2 of y to the 5th. Now, I wouldn't be able to do anything if these weren't the same base. So they are, and now the plus sign means that I multiply, so I've got log base 2 of x to the 6th times y to the 5th. Okay, let's look at a couple more examples of, again, condensing these. We're trying to make these where we only write the word log down one time. So for here, I have a plus sign and then a minus sign. So this 2 out in front means it's going to become a 2 squared. So if you look at log of 6 times, I'm going to not write the log down anymore. What does this mean? This means 2 to the 2nd power. The subtraction sign means division over 3. Well, now because I'm dealing with all numbers, I can actually do the math. 2 to the 2nd power is 4. 6 times 4, so I'd have log of 6 times 4 over 3, which is log of 24 over 3, which is log of 8. So this whole thing will reduce to log of 8. And again, if you have variables, you can't do anything once you have it condensed. But with numbers, you can continue to simplify and do the math. So here you have log base 3 of 7 squared over x to the 5th power. Again, notice we're only writing the log base 3 once, and then because I can do 7 squared, I've got log base 3 of 49 over x to the 5th power. This problem here, I'm going to write log just one time, okay? And then I'm going to do something a little different here, so pay attention. What does the 1/2 power mean? It means square root, and because this is a plus sign, I'm going to have 3 square root of x all over. The 3 goes here. Why did I put a division sign? Because it's subtraction, w to the 3rd power. Okay, now take a look. Notice the difference between this exam. That would be it. Done here. Look at the difference here. This was a 1/2 in front, which meant a square root. Okay, this is just the number 1/2. So this is going to be 1/2 to the 3rd power. So this 3 goes here. So I've got log of 1/2 to the 3rd power. Plus means to multiply, so plus 24, minus, which is a division sign, over 4 to the 2nd power. Again, because these are all numbers now, I can go ahead and simplify this. 1 to the 2nd, or 1 over 2 to the 3rd power is 1 over 8 times 24 over 16, which is 3 over 16. So this answer would be log of 3 over 16. Again, so when I say to condense things, we're only going to write the word log down one time. And again, anytime you see a plus sign, you should never have a plus sign in your answer. It automatically gets turned to multiplication. You should never have a number out in front. It automatically gets turned into an exponent. And you should never have a subtraction sign because that automatically gets turned into division. So just like in condensing, we're going to now expand these problems. Okay. So we're going to go the other way, where before I couldn't have an exponent. Now, if I have an exponent, I'm going to make that not multiplication out in front. Okay, so to do this problem, I've got log as my base. I'm going to take this 2 and put it out in front. So it's 2 times the log of x. This x squared and y are being multiplied, so I'm going to add it. I'm going to rewrite the log of y. So really, I'm taking any term. What is the first term? The x squared here. And I'm writing that in its own separate log. And then what's the second term? It's this y. I'm writing that in its term. So here I have log of 8 plus because they're being multiplied, the 2, which is my exponent, log x. Again, the more you get comfortable with these, properties, the easier this really becomes. Let's take a look at a couple of more difficult problems. Especially when we get down to here. But here we're going to actually have 3 different things that we have to rewrite this as. So I'm going to rewrite this as 3 log z plus 4 log x. And again, where am I getting this 3 from? It's the exponent. Where am I getting the 4 from? It's the exponent of the x. Minus, why a minus? Because it's divided by log y. Again, you can really write these out all in one step. So then here we got log of z to the 5th to the 1 to the square root. Just a little note here. This means z to the 5th all raised to the 1/2 power because it's underneath the square root. So what am I going to put here? I'm going to put a 5 over 2 in front of the z, plus, because I'm multiplying, 2 log y minus 4 log x. Okay. Let's take a look at example G here. For this example, notice there's 2 things on the bottom. So something a little bit different happens here. When I have on the top log 4 log y, where'd the 4 come from? That's the exponent. Minus, because I'm on the bottom now, 5 log x. Because the z is on the bottom, I'm also going to subtract that. So that would be log of z. So anything that's on the bottom, we put a subtraction sign in front of it. Same thing with this example H here. We've got 5 log z minus, again, this right here means the 2/3 power. So I've got 2 over 3 log of y And because these are both on the bottom, I subtract again, and it would be log x. So really I'm looking at how many bases I have is how many times I'm going to write down the word log in these problems. I want to take a look at an example just to show you in Delta Math. When we're looking at this and we're condensing here now, okay, they already have the log there in front of you. So again, when you're writing this problem out, oh, okay, never mind. I'm not going to be able to write on this, but I wanted to. What does this 7 do here? It is it's an exponent, right? So this would be b to the 7th, okay? Where'd you go? Hold on, let's do another problem here. Okay, so let's do this problem here. So this right here is a subtraction problem. Sorry about that. So I've got b divided by, and the z in front here, the z in front is the exponent. So I'm going to move that in front. So it's going to be d raised to the z power. Looks different, but as you can see, it already has the log there. So they just want the final condensed answer as you do this. And it kind of shows you how to do that. So let's look and see. Well, here we got one that's multiplication to put them together. So again, this first part is going to be c to the 2nd power. And then we're going to multiply because of this plus sign, and that would be d to the y power. Again, you don't have to, again, type the log in there. It makes it kind of simple for you to condense these things. So there's a few problems here that I'd like you to give a shot. We're getting close here to the end of Chapter 7 where we'll have a short little quiz after the next lesson on Monday.